Hey everybody, what we're going to be doing today is lesson 2.1D, linear patterns. So please follow along with your notes as I do the notes here. So today what we are going to be doing is creating linear equations based off these stages. So when I look at these stages, I want us to notice that I have on stage 1, 3 blocks. Stage 2, I have 5 blocks. Stage 3, I have 7 blocks. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. So if you could guess how many blocks would be on stage 4, well, the answer there would just be 9. So going up and down, I have 1, 2, 3, 4. So I'd have another fifth one. So let me go ahead and draw it, and you can draw this along with me. It would look something like this. So if we have that middle block, and then I would have, so I'd have that middle block, and then I'd have 1, 2, 3, 4. And I apologize why that looks so messy, but once again over here, 1, 2, 3, 4. So it has a total of now 9 blocks. So explain in words how the pattern is growing from one stage to the next. And all we would notice is, well, I notice that I am adding 2 blocks per stage. Okay, so I'm adding 2 blocks per stage. And it asks me, how many blocks are in stage 10? Well, let's look at this. If I have 3 blocks on stage 1, 2 blocks on stage 5, on stage 2, 5 blocks. Stage 3, I have 7 blocks. It looks like I'm just continually to add 2 every time. Okay, so what I notice on stage 10, I know I would have added 2 blocks each time. So let's look at this. Do we all agree that I added 2 blocks here, 2 blocks here, 2 blocks here? So I'm always adding 2 per stage. I'm literally adding 2 blocks. Then I am going to go ahead and then add again 2 blocks. Then again add 2 blocks. So I'm adding 2 blocks per stage. So I can write that kind of as an equation. I'm adding 2 blocks per stage. All right. So then on stage 10, if I'm adding 2, that would give me a total of 20 blocks. But if we notice this, we're always 1 off, meaning 2 times 1 is 2, but I have 3. 2 times 2 is 4, but I have 5 blocks. 3 times 2 is 6, but I have 7 blocks. So essentially what I need to do is add that additional block. This would give me 21. So we're basically, guys, just looking at the linear pattern. What is my rate of change? What am I going up by each stage? And it also asks me how many blocks would be on stage 0. Well, if we look at this, if I have 3, 5, 7, 9, if I go backwards to stage 0, I would go down 2 to 7, go down 2 to 5, go down 2 to 3, go down 2 to 1. So the amount of blocks on stage 0 would be 1. And now what it wants us to do is actually write our equation. So I'm going to help us out here. The total amount of blocks is equal to how many we are increasing by times the stage plus the blocks on stage 0. So in this instance, the total amount of blocks is equal to, well, once again, what am I increasing by? Oh, I'm going up by 2 each time. I'm going up by 2 each time. That means I'm adding 2 blocks for every stage. And then the other part is I need to figure out how many blocks were on stage 0. Well, if we go down 2 now, so if I started on 7, I went down to 5, started on 5, went down to 2, and started on 2 and went down to 1. So that would just be a plus 1 right there. Now it says use your equation to verify that the number of blocks on stage 10. Well, the number of blocks is equal to 2 times whatever stage I'm on. I'm on stage 10, and I'm going to add that one block. That would give me then the total amount of blocks is equal to 20 plus 1, which means, as we came up with before, 21 blocks. Now it says use our equation to determine how many blocks are in stage 100. Okay, so this would be total amount of blocks equals 2 times 100 plus 1. This would give me the total amount of blocks is equal to 201. Now what I want us to do is explain how each part of the equation is shown in the geometric model. And as we discuss, the constant is the amount of blocks on stage 0. So basically, whatever our rate of change is, whatever we're adding each time, we just got to go backwards to stage 0. Okay? Now, what about my coefficient? That's the number attached to S. So in this instance, it was 2S. And what that 2 represent? This is not a 5. This is an S. So what does that 2 represent? The 2 represented the amount of blocks we add each stage. Okay. So now what we're going to do is use the pattern to complete the following in table values. So I knew on stage 1 I had 3, stage 2 I had 5, stage 3 I had 7, and stage 4 I had 9. This is going back to this table over here with the geometric model. And what I want you guys to notice is we're just adding 2 each time. So it says state the rate of change. As a reminder, rate of change is what my increase in blocks all over my increase in stage. So over here, when I look at my increase, what is my increase from 3 to 5? I added 2. What is my increase from 5 to 7? I added 2. And my increase from 7 to 9, I added 2. And over here on my x values / stage numbers, I added 1. So now what we need to do is only look at the blue. The rate of change is 2 over 1, and that just simplifies to 2. It also asks you to state your constant first difference. Your constant first difference will always equal your rate of change, so it is also 2. Now it says explain how each part of the equation in b equals 2s plus 1 is shown on the tables. So let's start with the 2. The 2 is how much I'm increasing each stage. So every block, every stage I increase, the amount of blocks is increasing by 2. So now it says use the table values to graph this. So remember, there's one block that I really want to focus on to. Or stage was 0, I'd have 1 block. So if I were to graph these, at 0 I had 1 block, stage 1 I had 3, stage 2 I had 5, stage 4 I had 7. This pattern can continue. And you notice my rate of change is up 2 over 1, up 2 over 1, up 2 over 1, so on and so forth. So it says show the rate of the change on the graph. Well, the rate of change on the graph is I am going up 2 over 1, up 2 over 1, up 2 over 1. Actually messed up right there. Let me go and fix those really quickly. See if I can get this point. It should have been right here. Let me just... Perfect. Now they're in the correct spot. So my slope continues to be up 2 over 1, up 2 over 1, so on and so forth. Okay. So now it says, is the relationship proportional? Well, there's a few things we need to do here. I can look at my graph and I notice, no, it's not, because it does not go through the origin. So we would say no. And because there is no constant of proportionality, sorry, I'm running out of space. And I'm writing on my iPad today, guys, so if you're wondering why it's looking really, I don't know, jagged, that's why. Okay, so no, there is no constant of proportionality, and graph does not go through the origin. Does not, that's a does, my apology, go through the origin. All right, now it says explain how each part of the equation of b equals 2s plus 1 is shown in the graph. Well, the 1 is the y-intercept. And the 2s is your rate of change, your rise over run. Now it says, does the graph represent linear growth? Use the table values in the graph to justify your reasoning. Now, a linear growth will make a straight line on a graph and have a rate of change. So therefore, we would say yes. And the reason is because the graph is linear. And we have a rate of change. Okay, so now what we're going to do is go ahead and look at this pattern again. Sorry, just seeing what we got here. Over here, I have one block, then I have 1, 2, 3, 4, then I have 1, 2, 3, 4, 5, 6, 7, and then I'm going to have 10 on this one. And what I want us to notice here is every time we increase this stage, my values increase by 3. That means my rate of change, my slope, is 3. So on stage 5, I have 10 here. I'm going to have 13 blocks, which means I'm going to have 1 in the center. And then from that, we are going to have 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, for a total of 13 blocks. So it says how many blocks would be on stage 10? Well, let's think about this. If I'm always increasing by 3, and I am increasing by 3, but I'm always, my total amount of blocks is always like 2 less than my stage number. So 3 times my stage number of 1 is 3, but I only have 1. And then 3 times 2 is 6, but my answer is 4. 3 times 3 is 9, but my answer is 7. And then 3 times 4 is 12, and my answer is 10. So I notice that I'm increasing by 3, but I'm always 2 less than the stage number. So my guess is I'm going to do 3 times 10 to get my 30 blocks, but I'm always 2 less than the 3 times the stage number. So I'm going to guess is 28. The next part is how many blocks are on stage 0? So when I look at that, if I'm on stage 3 to 4, I go down 3. 4 to 3, I go down 3. 3 to 2, I go down 3. 2 to 1, I go down 3. And then on stage 0, I'm going to go down 3 again. Now, I know it's tricky because we're talking about physical blocks, but what we would have is -2 blocks. -2. So now remember the equation. It's the amount that I'm increasing by as my slope, is my rate of change. So that would be the total amount of blocks is I'm increasing by 3 each stage. And then I'm going to add what's on stage 0. And on stage 0, there is -2 blocks. So you're going to have a total equation of B equals 3s minus 2. Now it says explain how each part of the equation is shown in the geometric model. Well, your constant, like, once again, is the amount of blocks on stage 0. And your coefficient is your rate of change. So right here, we're talking about the 3s. And on the constant, we're talking about the -2. Once again, the rate of change is how much I'm increasing by. How many blocks do I go up per stage? All right, so now it says use your equation to verify the number of blocks on stage 10. So what this would be is, well, I have the total amount of blocks is equal to 3 times 10 minus 2. This would give me the total amount of blocks equals 28. Now it says use your equation to determine how many blocks are on stage 100. Well, the total amount of blocks is equal to 3 times 100 minus 2. This would give me then 300 minus 2 equals 298. Now it says on which stage will there be 58 blocks. This is a little different because my equation is B equals 3s minus 2, and it's saying I have 58 blocks. Figure out what stage that would be on. So all I'm going to do now is solve for s by adding 2 on each side to have 60 equals 3s. Then we're just going to divide both sides by 3 to have s equals 20. So on stage 20, we would have 58 blocks. Over here now, we can go ahead and complete the table values. So I had 1, then 4, then 7, 10, and finally 13. Now it says state the rate of change and show it in my table values. Well, in my table values, the rate of change is what I'm going up by. And I'm going up by 3 each and every time. And over here, we're going to divide that by how much my stage increases. So that means my stage increases by 1 each and every time. So the rate of change would be 3 over 1, which is just 3. Now it says explain how each part of the equation B equals 3s is shown in the table values. Well, the 3s is my rate of change, my change in y over change in x, how much my y increases over how much my x increases. That's the values that I divided over here. And my -2 would be at stage 0, there would be -2 blocks. So now let's go ahead and create this. I'd go to -2, and then at stage 1 there was 1, stage 2 there was 4, stage 3 there was 7, so let's see, 5, 6, 7, stage 4 there was 10, so on and so forth. And you can see the rate of change right here. I go up 3 over 1, up 3 over 1, up 3 over 1. So we just go ahead and did that. Is the relationship proportional? Does this line intersect at the origin? And we would say no, because it does not go through the origin. Now it says, explain how each part of the equation 3s minus 2 is shown on the graph. Okay, well, the 3 is the rate of change. And the -2 is the y-intercept. That's this value right here. It's where the point crosses the y-axis. And we would say, does the pattern show linear growth? And we would say yes, because it makes a straight line. All right, ladies and gentlemen, I want to pause right here. I want you guys to do number 5 all by yourself. There's going to be a video showing you how to do number 5 next, but I want to pause right here and have you guys do it. Okay, so you guys should have finished this already. If not, please pause and go ahead and finish it. But let's go ahead and show this now. It says how many blocks are being added from the one step to the next. Well, this is 1, 2, 3, 4, 5, 6, 7 blocks. And then let's see, 1, 2, 3, 4, 5, 6. And then we got 12, 13. This is 6, 12, 18, 19. 6, 12, 18, 24, 25. So it says write an equation that gives you the blocks. Well, what am I going up by each time? I'm increasing by 6. So the total amount of blocks is equal to 6s, but look at that. 1 times 6 is 6, but there's 7 blocks. 2 times 6 is 12, and there's 13 blocks. So what we need to do is take into account this top block up here, this one right here. And to do that, what we must do is add 1 each and every time. Now, if graph, what would the constant be on your equation represent on the graph? So that would be the +1, which is the top block. Okay? Now, if graphed, what would the coefficient of s represent? And this would be the rate of change, or the 6 blocks we add each time. Alright guys, that concludes lesson 2.1D. If you have any questions on this, please feel free to either email me or put your question in Google Classroom. At this time, guys, you may start your homework. Homework is 2.1D. I also post the video for that in Google Classroom. Have a great day, guys.